Section 3.2. What's unusual? The empirical rule and the z-score. For these sessions, we're going to talk about the usual and unusual value, and then we're going to introduce the empirical rule and the z-score. So first, talk about the empirical rule. Empirical rule is a rough guideline for the approximate percentage of the data within 1 to 3 standard deviation of the mean in unimodal symmetric distribution. So empirical rule only work for the symmetric distribution, and also unimodal means they only have a one mark of it. So look at this picture. This is a normal distribution, and this is a symmetric, and we only have a one mark. So if we do have the normal distribution, then the mean will be the typical value, the highest point in here. Remember, we say majority of the data will be within one standard deviation. So this is talking about the mean plus one standard deviation, and this is the mean minus one standard deviation. So the majority of the data, this is talking about 68% of the data will within one standard deviation. Okay? And then when I use the mean plus 2 standard deviation, okay, this is a 2 standard deviation, and then minus 2 standard deviation, including that 68%, we do have 95% of the data will be within 2 standard deviation. Okay, then the mean plus 3 standard deviation, and then the mean minus 3 standard deviation. So including the 68% and the 95% in here, that will be the 99.7% will be within 3 standard deviation of the mean. So this is the empirical rule. Okay, one more time, empirical rule only applies for the unimodal and the symmetric distribution. And I need you guys remember this 3%. 68% will be within 1 standard deviation. 95% will be within 2 standard deviation. And then 99.7% of the data will be within 3 standard deviation. Okay, so this is the empirical rule. Okay, let's try to do this example. Data on smoke levels in a sample of cities was collected, and the distribution was found to be roughly symmetric and unimodal. So this is symmetric and unimodal. The mean particulate level for the samples was 10.7 micrograms per cubic liter, within a standard deviation of 2.6 micrograms per cubic liter. According to the data of this example, we will have this idea. The mean is going to be 10.7, okay? And then standard deviation will be equal to 2.6. So how can we get this one? That will be 10.7 plus 2.6, which is going to be 13.3. And then the mean, 10.7 minus 1 standard deviation, which is going to be 8.1. So within this part of the data, according to the empirical rule, 68% of the data will be within 1 standard deviation. Okay, so we could draw the conclusion. About 68% of the city will have smoke level between 8.1 to 13.3. And then we're going to calculate for the 95%. So the mean plus 2 times 2.6, that will be 15.9. And then 10.7 minus 2 times 2.6, which is going to be 5.5. And that will be 95% of the data. So I'm going to draw the conclusions like this. About 95% of the cities will have a smoke level between 5.5 to 15.9. Okay, last one. Nearly all, this is talking about 99.7%, okay? So same idea, use the mean minus 3 times 2.6, which is 2.9. And then 10.7 plus 3 times 2.9, that will be 18.5. So draw the conclusion about 99.7% of the cities will have smoke level between 2.9 and 18.5. They didn't draw the normal distributions here because on the example, they never mentioned about what kind of the distribution is it. But we want to apply the empirical rule. We only can believe this is going to be symmetric and unimodal. For the empirical rule, I need you guys calculate this kind of the number with 1 plus minus 1 standard deviation, plus minus 2 standard deviation, and plus minus 3 standard deviation. And then I need you guys remember like all this percentage. 68% within 1 standard deviation. 95% within 2 standard deviation. 99.7% within 3 standard deviation. Okay? On the exam, if I put this kind of the questions, I need you guys write in complete sentence. Okay? Don't just say 68% ... between two numbers. Okay? I need a complete sentence for this free conclusion. Unusual observation. If a distribution is unimodal and symmetric, the answer lies with the empirical rule, which states that 95% of the observations are within 2 standard deviations of the mean. This means that only 5% of the observations are more than 2 standard deviations away from the mean. So, if an observation is more than 2 standard deviations away from the mean, we will refer to the observation as unusual values. So look at this picture here. The 2 standard deviation, okay, they're talking about if more than 2 standard deviation away from the mean, we consider this part of the data will be unusual. Or if the observation is less than 2 standard deviation away from the mean, which is this part, we consider this data will be unusual. So when you add up these two parts here, it's roughly about 5%. Okay? So maximum unusual, and the minimum unusual. Maximum unusual, this is talking about the mean plus 2 standard deviation. Minimum unusual will be the mean minus 2 standard deviation. So you could think about it. This is gonna be the point here. If the data exists at this part, we consider this is maximum unusual. If less than the minimum unusual, we consider this is a minimum unusual values. So I would draw the picture like this. Okay, any data within 2 standard deviation, that's a 95%. We consider this is a usual value. If the data below the mean minus 2 standard deviation, this is unusually low. If the data more than mean plus 2 standard deviation, we consider this is unusually high. I need you guys remember these two formulas. Every time when we're talking about unusual value, you're going to think about these two formulas. Okay, finding the mean and the standard deviation. Look at this example. The mean daily high temperature in San Francisco is 65 Fahrenheit with a standard deviation of 8 Fahrenheit. Find the temperature range for 68%, 95%, and 99.7% of the data. So remember this 3%, 68, 95, and 99.7. This is talking about the empirical rule. So we want to find the range. So I show you guys the first one. 68% of the data, that will be within 1 standard deviation. So I will use the mean plus minus the standard deviation. Okay, the mean plus minus standard deviation. So you will find 68% of the daily high temperature in San Francisco is between 57 Fahrenheit to 73 Fahrenheit. And then I want you guys try to find the 95% and the 99.7% of the data. Okay, check your work. 95%, that will be plus minus 2 times the standard deviation. This is 2 times H, which is equal to 16 Fahrenheit. Last one, 99.7%. So this will be the mean plus minus 3 times the standard deviation. Okay, 3 times H, which is equal to 24 Fahrenheit. Okay, number 2. Using the empirical rule, decide whether it is unusual to have a day when the maximum temperature is colder than 49 Fahrenheit in San Francisco. So, talking about the unusual values. So remember this picture? The mean plus minus 2 standard deviation. Outside this part, that will be unusually. Okay? Okay, look at this picture. This is an empirical rule. So the distribution has to be symmetric and unit model. Okay, so in the middle here, that will be the mean, which is gonna be 65 Fahrenheit. Okay, talk about usual and unusual. So that will be these two guys. That will be the mean plus 2 standard deviation. And this will be the mean minus 2 standard deviation. Okay, so we find it from the example 1 here, which is 49 to 81. Okay, so this is equal to 49 Fahrenheit. This is gonna be equal to 81 Fahrenheit. Okay, so one more time, within here, within 2 standard deviation, that will be usual. And then, like here, starting from here, that will be unusual. Okay, unusual. And right now they're talking about which the maximum temperature is colder than 49 Fahrenheit. So colder than, so it will be like this, but the 49 in here. So this is gonna be unusual value. So you could use the picture to explain why it is unusual value. Okay, and then answer the question. Having a temperature colder than 49 Fahrenheit in San Francisco is very unusual. C-score of an individual data value tells how many standard deviations that value is from its population mean. So look at this picture here. Okay, what does a C-score means? C-score is tells you what is the standard deviation above or below the mean. Like here, C-score equal to 1. It means this is 1 standard deviation above the mean. If Z-score equal to 3, that means 3 standard deviation above the mean. Okay, like here, -2. C-score equal to -2 means we do have a 2 standard deviation below the mean. Okay. Example 3. The dot plot shows height of a sample of men. How many men would have a C-score? Try to do it by yourself. Okay, check your work. C-score equal to 2 means this is a 2 standard deviation above the mean. Okay, so you can count 1, 2. 2 men have a C-score greater than 2. Okay, less than -2, less than this one, we still have a 2 here. 2 men have C-scores less than -2. Okay, look at this example. Z-scores allow us to compare observation in different distributions. Suppose wall A has a mean speed of 60 miles per hour with a standard deviation of 5 miles per hour, and wall B has a mean speed of 60 miles per hour with a standard deviation of 10 miles per hour. So I just write down the information here. Wall A, we do have the mean 60 miles per hour. Standard deviation, we use the S equal to 5 miles per hour. And then wall B, you could see they do have the same mean here, but they have a different standard deviation. Is a driver going 70 miles per hour on wall A traveling relatively faster or slower than a driver going 70 miles per hour on wall B? Okay, when you guys want to do the compare observation in these two different distribution, we want to use the Z-score. So this is the formula, how you guys finding the Z-score. Z-score equal to the data value. So in this example, you want to use the 70. Miles the mean, 60 divided by the standard deviation. So for the wall A, we're going to be divided by 5. For the wall B, we're going to be divided by 10. Okay, I need you guys remember this Z-score formula. Okay. Okay, I want you guys try. I show you guys how you find the Z-score on the wall A. Okay, the data 70 minus the mean divided by the standard deviation, which means the Z is going to be equal to 2. Okay, Z-score equal to 2 means there's a 2 standard deviation above the mean. I want you guys try to work on the wall B here. Okay, check your work. You're gonna see the Z-score equal to 1. So, is a driver going on wall A is faster or slower? This one is equal to 2, right? So, driver on the wall A is traveling relatively faster than the driver on the wall B. Okay, we use the Z-score to compare for it. Okay, I want you guys try the last example. Try to write down the information first and then calculate the Z-score for each exam. And then you could compare for it. Okay, check the work. So for the first exam, you will find Maria's score is 80 minus the mean divided by the standard deviation. Okay, which is going to be equal to 1. And then for the second exam, we have a 85 minus the mean divided by the standard deviation is also equal to 1. So that means the second exam was a little easier. Okay, you got the higher points in here, but actually the standard deviation is also equal to 1. And you could see Maria did equally well on both when compared to the whole class.